Here we've got the trig integral, sine to the 5th power x times cosine squared x, and because we've got sine to the 5th power, that is odd. So in order to use our substitution properties of cosine x, or cosine squared x, equals 1 minus sine squared x, or the other way around, sine squared x equals 1 minus cosine squared x, we want to get one of these, particularly usually the one with the odd power to start with, to have 1 on its own. And so what we can rewrite this as is the integral of sine x times sine squared x squared, to make that 4, times cosine squared x dx. And so now we have one single cosine alone. And so what we can do once we've done that is we can substitute this sine squared x in for 1 minus cosine squared x. So then we have just one sine x, and the rest of the terms are in terms of cosine. So expanding this, we now have the integral of sine x times sine squared x times sine squared x once more. I'm just expanding this squared term, times cosine squared x dx. And now we can go ahead and plug in the 1 minus cosines. We have the integral of sine x times 1 minus cosine squared x times 1 minus cosine squared x times cosine x squared x, dx. And now that we're here, we can do a u-sub. We can let u equal cosine x, and the derivative of u is negative sine x. And so what we can do is we can take this negative, put it out front of our integral, and then do the integral of, in parentheses, 1 minus u squared times 1 minus u squared times u squared du. And now we can simplify this integrand, and we can say the negative integral of 1 minus 2u squared plus u to the 4th power times u squared du. Simplifying once more, we get the negative integral of u squared minus 2u to the 4th power plus u to the 6th power du. And now we can go ahead and integrate. So what we get is negative, and then in brackets, u to the 3rd power over 3 minus 2/5 u to the 5th power plus u to the 7th power over 7, and then at the end here add a constant because we're dealing with an integral with no bounds. This is an indefinite integral, therefore we must add a constant. Finally now, we just need to distribute this negative and then substitute back in for u. So distributing the negative, we get negative u cubed over 3 plus 2/5 u to the 5th power minus u to the 7th power over 7 plus c. And then finding our u, we see that it's cosine x, so we just go ahead and plug that back in. And here we end up with negative cosine cubed x over 3 plus 2/5 cosine to the 5th power x minus cosine to the 7th power x over 7 plus c. And this is the final solution to our integral. If you've got any questions, or if you'd like me to tackle any other calculus or physics problems, let me know in the comments below. Otherwise, I hope that you found this helpful.